Hello, this is Dr. Hassan Abdullah. I'm here with the course Introduction to Natural Language Processing, and this is lecture 3. And in this lecture, we will be covering the bag of words model. And in the second part of this lecture, we will be covering the vector space model. So the supplemental website for this course is on the screen, www.easymcq.com/goget. So these are the topics which are covered in this course, and right now we are covering topic number 3. And just to give you a brief overview about the learning management system, the URL is on your screen. So you can see there are quite a few features and facilities of this learning management system which will enable and help you in getting the most of this course. And this is explained in these 6 videos for your happy facilitation. So we are now at the supplemental website, and as you can see there are quite a few courses here, and for example, data structures and algorithm, which is a core computer science course. Of course, this course, natural language processing, machine learning and AI, and you are welcome to explore these courses and learn from them. So now we focus on the course of our interest, which is the natural language processing, and the topic of our interest is the bag of words model. So what is the bag of words model? So in this model, basically, before we move ahead, so what is the model itself? So we are working with text in natural language processing, say for example, to begin with, and it is doesn't make any sense. So adding text and multiplying text, subtracting text, and finding the correlation between text and so on. So we need to convert the text into numbers, and that is the modeling part. So basically in the bag of words model, this is a vocabulary based representation. Vocabulary is the words which occur in the documents we are working with. Word frequency is how many times a word occurs across the document set. And order ignorance, we don't we don't take into consideration the order of the words, because we are just looking at the frequency counts. Why? Because it's a very simple approach, and this results into sparse vectors. So basically a vector is a representation that which words occur and which words do not occur. And of course, if you look at the vocabulary can be quite large, and it is unlikely that all the words occur in all the statements of the document. So it's a very sparse vector. There is no semantic meaning because we are just looking at the frequency. We don't look at the order. So there is no contextual information, and it results in a very high dimensional vectors because there are quite a few words, and as the number of documents increases, the words increases, and it has to handle the sparse data and bag of phrases also. So what is the bag of phrases? N-grams were sequence of n words rather than the individual words. For example, action based. So action based is it is a bigram. All right. So what are the pre-processing steps needed prior to using the bag of words model? It's not just you look at the statements or the documents and then start creating these matrices and those vectors. A lot of processing has to take place. So what are those pre-processing steps? Those pre-processing steps are tokenization, which I briefly mentioned, and lowercasing, converting all the text into lowercase. Of course, there is a downside to it, because if we have Apple written with a capital A, that is the name of a company, a very valuable company, and Apple written with a lowercase a is a fruit. So because if you don't do that, then the computational complexity is tremendous, and there are quite a few variations. So removing the punctuation so that it's standardized, and removing the stop words such as is, the, and of course it has its downside also, which we have discussed. Stemming or lemmatization, so ran, running, and run, so reduced to run, and lemmatization, better, reduced to good. Removing special characters and numbers because they again add to the computational complexity, and those special characters, they may be constituted as towards noise. Handling the rare words which occur very less frequently. Handling multi-word expressions, which is optional, and normalizing or scaling the frequencies. So normalizing the scaling frequency vector, you choose to normalize the term frequency of words to account for document length variations. So that all effort goes into then what we do, and of course if you want to learn more about it, there are the references for you. So let's look at very simple examples which are not so simple, but well, they are also simple because the number of words are quite limited. So the text 1 is the child makes the mother happy, and the text 2 is the mother makes the child happy. And if you look at the working, so what happens is that these are the two texts we were referring to, and we perform the tokenization. We break the text into single words. So this, in this case, is a unigram, and then we build the vocabulary. So vocabulary consists of all the words which are common among those documents, and then we have this do a frequency count for text 1, we do a frequency count for text 2. The letter the appears twice and others appears only once. So then we have this frequency count vector for the first text and the second text also, and then is the final table. This is the final table. So we see that interesting enough, we see that both the statements, which are quite different, they have the same representation. So this is a limitation, but of course we have a simple approach to it. So that was one limitation I mentioned. So what are the other limitations of the bag of words model? So loss of word order, as we saw that in this case the child makes mother happy, but the statement the mother makes the child happy, that is gone, right? So loss of word order, ignoring the context. So since the word order is gone, ignoring the context. So for example, the word bank can either be financial institution or the river bank, but when we ignore the context, then there is no way we can figure out what the bank actually meant, and it results in high dimensionality because it's highly sparse, because all the vocabulary words, if they are not repeating, they will result into a high dimensional space with the curse of dimensionality. Inability to handle synonyms. So for example, the words happy and joyful would be treated as distinct features, while in reality they point to the same meaning. And of course, handling polysemy and word bark, which the sound made by the dog, and the bark is the skin of the tree, and of course that is gone. Sparsity I have already discussed. No information about the word frequency. Okay. So example, the is and may dominate the representation, but when we are not looking at the frequency, it is gone, right? Scalability issues, scalability problems. As the vocabulary grows, the model becomes increasingly difficult. The space complexity is very high, and lack of semantic information because the order is gone. So the semantics are gone. But of course, we have something to start with, to work with. So what is the issue of negation in the bag of words model? Negation, there is one simple negation. For example, I love NLP and I do not love NLP. And of course, in this case, the sentiment is not very difficult to understand. And there is no ambiguity. But for example, if we have this, I give you a more complex example. Yeah, you can read this material. This is the example. No laughs and many dull moments. Okay. Many laughs and no dull moments. So these statements are entirely different. As a matter of fact, they are opposite to each other. But because of the limitation of the bag of word model, these limitations will not be, it will be hidden, as a matter of fact. So this is the issue with the bag of word models. And of course, now we move on to the vector space model.